So the presentation will be 15 minutes, which should be about 12 minutes or so. If you run out of time, if you start running out of time, I'll wave at you or something. When do you want a time signal? We'll look to the end. You're going to finish in 17 and a half minutes? Well, then you just better crank up that baud rate just a little bit. Okay? So, I need to find it. God, it's busy. It's a crowded place. The only good seats are gone. Sorry. I wouldn't sit that close.
We are the Artificial Amazons group, and I'm presenting myself, Hussam, Ahmed.
Take the PhD out.
Nice.
You like it? Actually, one of our features. Okay, me, myself, Hussam, we have Ahmed, Gino, and Muhammad. And basically, I'll just go straight to, the agenda, I guess. We spent some days to figure out our basic model. We wanted, the software, at least, we want it to be correct. It would, tell us if we did a wrong move. It won't really, we don't want the game to be ended too soon. We spent some time with the connection to the server. Thanks to the professor, he gave us a class that made the connection with the Java much more easier. We spent a lot of time developing a custom, way to deal with the game. Basically, in our software, in order for us to learn the game, we tried to have the software adapt to our needs. So sometimes we do a 4x4 table or a 5x5 or 6x6, and we wanted, for example, to put the Amazon players in a variety of places with the blocks being filled or not, so then you can use our strategies or win the game in a faster pace. And in this stage currently, we're going through the strategy development and testing, basically. Probably documentation will be later.
One of the first questions we had to answer was what platform we were going to use to develop it. We were deciding between Java, C, and Lisp. Lisp was one of the first things we decided not to use because we weren't as used to it as Java and C. With Java and C, we had some of the obvious trade-offs. I like developing on Linux, and compatibility was an issue because C code isn't always portable, whereas Java code is always portable. And execution speed versus ease of use. C, you get a lot of problems with segmentation faults, null pointers, the sort of stuff that would break the program. That's not the sort of thing we wanted while we were developing a strategy. So we decided at first to develop the environment for testing our strategy in Java with the idea in mind that we would eventually port it over to C for extra speed, and that we would sort of develop some of the other things we needed concurrently in C, like connection code, stuff we were using for data structures, so that when we finished and we had the best strategy, we could port it over to C. We eventually decided not to do that and just to stick with Java because we decided that the best strategy is going to trump any sort of speed advantage. We also had the trade-offs with the network connection already being written in Java and provided by Professor McCartney. And in the end, we chose Java for all those reasons where the strategy is the best, it's easiest to work with, and we wouldn't have problems with memory management.
So, in the beginning of the project, we thought about should we use the speed or should we use a good strategy for winning the game? We did some, we divided the group into, and one of parties was working on the strategy and other part was working on the, how fast can we do it? Because in the beginning of the project, and actually, if you do the exhausting search and when you go to the deepest level, and that means you're gonna win the game 100%. But we just calculate some time. Actually, we wrote the program, we coded the program. How fast can we do with the C and how fast can we do with the Java? C is maybe 7 times faster than Java, but the problem is really hard to with the C or very low level language. That's why we stick with the Java. But before that, we try to do very good data structure, which is our very important feature that we thought, which is we try to use network-based data structure, which is you're getting the state, putting in the instead of putting in array or putting the object, we just encoding some numbers and to the integers, and that's gonna be save a lot of space, and you can save million states in a very small small space. But the problem is every single time you have to encoding and decoding, and it's gonna be make really time. That's why we stick with the array object array just 0 and 1s. And the other problem is we have to make sure the game is gonna end it in 5 minutes, because time is very limited, and when you go deeper and deeper, it's not really 100%. You're going to correct space. That's why we go with the heuristic strategy, which is not 100% the answer, but possible the best move for winning the game. You can show some demo.
Some remarks here and there. So basically, just to remember our course, what is a state? We store the state in a basic class, which has all the contents, basically in a two-dimensional array, with also the current player's turn. Now, this describes the state. And for each strategy that we want, we basically supply it with these types of information. Basically, the available moves that the player can do, the time limit, you have 5 minutes or less. So this will help us at least. Like one of the depth breadth search does take into consideration the time factor, so it doesn't go too deep. And it's often, and for each move, it tries to calculate the average time the last move took, so it can adapt and take more time, for example, if it senses that it has more time for the end of the game. And also a lot of tools that might help. The backpack, tools backpack. A lot of methods that the strategy can use, which are very common for all strategies. These are just some of the, we brainstormed basically the complete search tree, which didn't really make any, I'm not sure if it's feasible, it's not feasible at all. The minimum, maximum methodologies, some evaluation ways to how to evaluate the other party versus the party. We were trying to think of a way to how to corner the other people, but we're not really clear into that framing. And also, if we can have a way, like a strategy that would understand the different states of the game so that it would adapt a different strategy. We're into that still. We're trying to see. I guess.
So here what we wanted to do, because we have lots of strategies, we have lots of ideas, we wanted to create a framework which is intelligent enough to enable us to add any strategy we want, and to be able to modify the strategy simply and add the strategy simply without redo everything or re-encode everything again. So we have done, we have used an object-oriented architecture here. So as an example, to create a new strategy, what you need to do, or everyone who wants to add a strategy, just create new strategy and inherit this strategy from the strategy class. Here you can just add a name, and what you need to do is just create your evaluation function, because each strategy is a difference between each strategy and another one is evaluation, how to evaluate the state and how to evaluate the next state. So this is the basic one to create a strategy. And to create a strategy, we need lots and lots and lots of helper function. As an example, a helper function to get all next state, a helper function to evaluate my state, a helper function to get the surrounding area around it means, a helper function to get is this my turn or is this the opponent's turn. So each strategy uses those helper functions. Actually, just not all the helper functions that we have, those are just some of helper functions. Next. And here is the packages that we use. Here we have the Amazon package. Here is the main game. Here is the board package. This package contains the definition, the data structure of the board. This package contains the data structure for the address and the data structure for the move. And the player package is the package that has different types of players, because we have a human player, we have a strategic player, we have a random player. So every player is embedded in this package. And strategies, this package is the strategies. Any strategies we add is embedded in this package as a class. Here is a remote package that has a line that connects to the remote machine and the server that your professor gave to us, thanks to you. Everything to play with a remote player in this package. The store stores the history to be able to go back at any point and interject the game with any state. And the UI, this package contains the UI in the board and the buttons and everything related to the user interface. This is an example of the packages and the classes inside each package. So the board package contains the board class, which is actually data structure, the address, which is row column, and the move, which is from, to, and fire. This is a move. Here we have a players. Actually, all classes here are extended from this player. This is the generic one, and all other classes are extended from this class. Here is the strategies. Here is the classes that we have, the complete depth. I guess weighted, and the depth is inherited from the complete depth. I don't remember exactly the hierarchy. There is another figure for the hierarchy, but all of these classes, all of these strategies here are extended from a generic strategy one. And here we have a remote package that contains Amazon Client class that connects to the server and play. Here we have the hierarchy. We have the generic player class that we can extend from it, the command line human player, which is the human can play this game. Here we have the computer player, and from the computer player we extend the strategic player, which uses the strategies, or actually it uses the strategies that we give him to play the game. Next. And here is the hierarchy of the strategy. There is a more generic one. There is a group, as an example we have here. Minimum list strategy, it has some properties and some evaluation function. The other strategies are extended from this strategy as they have the common way for evaluation, but there is a different implementation for evaluating the state and generating the state and evaluating which one is better for us and the worst for the opponent to play. Any questions?